Okay, let's unpack this. We are about to dive into a topic that usually splits a room of developers faster than tabs versus spaces.
Oh, for sure.
We are talking about PHP. And honestly, I can practically hear some of you rolling your eyes right now.
I could feel it.
I mean, come on. PHP. Isn't that the language that, high schoolers were using back in 2004 to make a guest book? Isn't that the thing that powers all those hacked WordPress sites?
It's the reputation that precedes it. Absolutely. It's like the Nickelback of programming languages for some people.
That is a perfect analogy.
But if we look at the raw data, and more importantly, the modern ecosystem, the reality is, well, it's starkly different. We aren't here to talk about the PHP of 2012.
Right.
If that's what you think PHP is, then sure, be skeptical. But we are here to talk about the brutal truth of the internet today.
And that truth has some pretty heavy numbers attached to it, doesn't it? I was looking at the source material you brought in, and the market share is just kind of shocking.
It is unequivocal. PHP powers roughly 75% of the web, 3/4. So whenever someone on Twitter or Hacker News says PHP is dead, they are statistically speaking ignoring the vast majority of the internet's infrastructure.
It's a rounding error to them.
It really is. The source calls it the blue-collar worker of the web, and I think that's perfect. It shows up, it does the work, it's pragmatic, and it's absolutely everywhere.
I love that analogy, the blue-collar worker. It's not necessarily the shiny, trendy startup tech that gets featured on the front page of tech blogs every day.
Not at all.
It's not the hype beast, but it's the engine room. However, we have to address the elephant in the room, pun intended, considering the logo. We have to talk about the bad old days.
We do, and we can't pretend they didn't happen. The source material is very honest about this. PHP started as a template engine. I mean, it literally stood for personal homepage.
Right. Rasmus Lerdorf just wanted a way to track visits to his online resume, is that right?
That's the story. It wasn't designed to be a proper programming language.
Yeah.
And that legacy, it left us with some scars. The classic example everyone cites, and it drives me crazy to this day, is the standard library inconsistency.
Oh, you mean the needle in the haystack debate?
Exactly. The order of the arguments. You have strophes, haystack, needle.
Can't curse.
Then you have a race search, needle, haystack.
At first?
It flips for no logical reason other than, history. It's maddening. And yes, because PHP is so permissive, it historically allowed really terrible developers to write really terrible code that, and this is the kicker, still ran.
That's the blessing and the curse, right? I remember back in the day, you could copy-paste a snippet from a forum, drop it into a file, and it worked.
It just worked.
But then you ended up with this unmaintainable spaghetti code that was an absolute security nightmare.
Precisely. It was the Wild West.
Yeah.
But here is the thesis for our deep dive today, and I want to be very, very clear about this.
Let's hear it.
If you are writing PHP like it is 2012, you are a liability, you are dangerous to your company. But if you're writing modern PHP, and we're talking version 8.1, 8.2, and beyond, it is a completely different beast.
How different are we talking?
It is strictly typed, it is fast, and honestly, it looks a lot more like Java or C# than these script kiddie snippets of the past. It's a grown-up language now.
So the mission today is to bridge that gap. We're going to look at the modern toolchain, the syntax evolution that forces you to write adult code, and the architecture that powers high-scale apps.
That's the plan.
Let's start with the basics. The tools. The source material is pretty aggressive here. It just says, stop using XMPP.
It is. And for good reason. Look, if you are still dragging a folder into XMPP or NMPP on your laptop, you are polluting your local machine.
What do you mean by polluting?
You're installing a version of PHP and MySQL directly onto your operating system. What happens when you need to work on another project that uses an older PHP version?
It's a mess. You have to uninstall, reinstall. It's a nightmare.
Exactly. You're creating an environment that looks nothing like production. The first non-negotiable in modern PHP is dependency management. And that means you have to use Composer.
Composer, it's the package manager, right? Like NPM for Node or Pit for Python?
Correct. It is the de facto standard. Gone are the days of manually downloading a zip file of a library, unzipping it into a lib folder, and writing require file.php at the top of your script.
I'm having flashbacks.
That is ancient history. Composer handles all of that. But the real magic isn't just downloading files, it's the autoloader.
How does that change the workflow? Because I remember having files with 20 requirement statements at the top. It was so brittle.
And if you got the order wrong, the whole thing crashed with a fatal error.
Right. Class not found.
Composer generates what's called a PSR4 autoloader. This is a standard that maps your namespaces, which are basically your folder structures, to the actual file paths automatically.
So I just say use app services billing and it just finds it.
PHP knows exactly where to find it on the disk. It's seamless. It lets you organize your code logically without worrying about the include paths.
That sounds like basic hygiene at this point, but there is a more critical aspect to our word. Composer that I see junior developers, and honestly, some sloppy seniors miss, the difference between composer.json and composer.log.
Oh, this is the big one. This is where so many teams shoot themselves in the foot.
I've seen this trip people up. They commit the JSON file, but they put the lock file in their .jitinor. They treat the lock file like a cache artifact, something you can delete and regenerate if it gets annoying.
Oh, that gives me palpitations just thinking about it. The composer.json file is a list of your requirements. It says, I need this library, version 1.0 or higher.
Even its wish list.
It's a wish list.
Yeah.
If you delete the lock file and run composer install, you are essentially rolling the dice. You're telling PHP, go find whatever is the latest version that matches my broad requirements.
So if a library developer released version 1.0.1 5 minutes ago with a breaking bug,
You get the bug. And your colleague, who installed the dependencies yesterday, doesn't. Now you have the classic, it works on my machine problem, but weaponized across your entire team.
okay, so what does the lock file do differently?
The lock file isn't a wish list. It's a snapshot of history. It's a recording of the exact versions that were installed. It says, we are not using version 1.0, we are using this specific commit hash, guaranteeing that production is a perfect clone of your laptop, down to the byte.
So the rule is always commit the lock file.
Always, without exception. It's the manifest of your application's dependencies.
Okay, so we have our packages managed correctly. Now let's talk about actually running the code. The source mentions abandoning Apache mod PHP. That feels like the end of an era. I feel like everyone started with .htaccess files and rewriting URLs.
It is the end of an era, at least for high-performance apps. The industry standard now is Nginx coupled with PHP FPM.
FPM stands for Fast CGI Process Manager. What makes it so much better than the old Apache way?
It's all about architecture and isolation. With ModPH, PHP is embedded inside the Apache process. They're tied together,
So if PHP goes down, Apache goes down with it.
or at least that request handler. When you use FPM, you have a separate, dedicated pool of worker processes. Think of them like employees waiting at a counter. When a request comes in from Nginx, a worker picks it up, executes the PHP script, and then resets itself completely.
And then they go back to the pool to wait for the next customer.
Yes. The key benefit is that isolation. If one request crashes, maybe it hits a memory limit or encounters a fatal error, it only takes down that single worker process.
The rest of the pool is unaffected.
Exactly. The main FPM process just spins up a new worker to replace the dead one. It prevents one bad request from bringing down the entire server, which was a very real risk with the old thread-based models. It's built for resilience.
That sounds much more robust. Now, before we even run the code, the source brings up something called static analysis. This seems to be a huge part of the modern workflow that just didn't exist 10 years ago.
It is arguably the biggest shift in the last 5 years for professional PHP development.
So what is it?
Because PHP is an interpreted language, historically, you wouldn't know you had a type error until the code actually ran. If you passed a string to a function expecting an integer, you'd find out when the user clicked the button and the page crashed.
Which is terrifying for a production app. It basically means your users are your beta testers.
Exactly, which is unacceptable in any professional setting. So tools like PHP Stan and Psalm were created. They are static analyzers. They read your code without running it. They analyze the logic flow, understand the types, and enforce type safety before you ever deploy.
So it's like having a compiler checking your work, even though there isn't really a compilation step.
It acts exactly like a compiler's type checker. You configure a strictness level, usually from 0 to 9. You might start a legacy project at level 1, but the goal is to get to level 9, which is max strictness.
And what does that catch?
It catches everything. If you claim a function returns an integer, but there is a single logic path where it might return null or a string, PHP Stan will scream at you. It forces you to write honest, predictable code. It eliminates entire categories of runtime bugs.
Okay, so that's a huge shift in tooling. Let's move from the tools to the code itself. You mentioned adult code earlier. The source talks about syntax evolution. What's the headline here?
The headline is strict typing. And this is where the old school PHP developers usually start getting uncomfortable.
I have to be honest, when I first saw strict typing in PHP, I kind of hated it.
You are not alone. A lot of people did.
It felt like PHP was trying to be Java. The whole joy of PHP, the reason it was so easy to learn, was that I could throw a string at a function and it just figured it out. Why do I want the language to scream at me because I passed a string 5 instead of the number 5?
Because that joy is actually a trap. When you're building a personal blog, that magic typing is fun. When you're handling financial transactions, magic typing is a lawsuit waiting to happen.
That's a good point.
If you rely on PHP to guess what you mean, eventually it will guess wrong, and the bug will be subtle and destructive. The modern fix is a mandatory header at the top of every single PHP file. Declare.
Strict types 1. And that just turns off all the helpfulness.
It turns off the dangerous guesswork. It forces discipline. Now, if you pass a string to an integer argument, PHP throws a type error exception immediately.
Yeah.
It fails loudly and early. It forces you to be explicit about your data, which is what you want in a large application.
It sounds like it removes ambiguity.
That's the entire goal.
Yeah.
The source also highlights something called constructor property promotion.
Yeah.
That sounds like corporate jargon, but looking at the code snippets, it looks like a huge time saver.
Tell me about it.
It's a wonderful quality of life improvement from PHP 8. And the old garbage way, as the source so elegantly puts it, if you wanted a class with 3 properties, you had to define the properties at the top of the class, then you had to write the constructor arguments, and then inside the constructor, you had to assign the arguments to the properties. You were writing the same variable names 4 times.
I remember that vividly. Private name at the top, constructor name, and then this name, yes, no name, over and over and over again. It felt like filling out tax forms.
With property promotion, you do it all in one line. You just define the visibility and type directly in the constructor signature. Public function, construct, public string name. That's it.
That's the whole thing.
That's the whole thing. Cuts the boilerplate down to almost nothing. And when you combine that with read-only properties, another new feature, you get guaranteed immutability.
Read-only means once it's set in the constructor, it can't be changed.
Correct. It can be written to exactly once during initialization and never again. This is critical for robust design, because it guarantees the state of your object won't change unexpectedly halfway through a request. If you have a user object, you don't want the user ID to suddenly change because of a bug in some other part of the code.
That provides a huge level of safety.
It really does.
One syntax change that really caught my eye is the battle between match and switch. I feel like switch statements have been around since the dawn of C. Why are they suddenly considered flawed?
The fatal flaw in switch is that it uses loose comparison. The double equals.
So it does type juggling.
It does type juggling. So in a switch statement, the string 0 might equal the number 0, depending on the context. Or worse, null might equal 0 or false, depending on how PHP feels that day. It's unpredictable and dangerous.
And match fixes this.
The match expression, introduced in PHP 8, uses strict comparison, triple equals.
Yeah.
So there's no ambiguity. But it's also an expression, which means it returns a value.
What's the benefit of that?
You can assign the result of a match directly to a variable, which cleans up the code immensely. Plus, it handles exhaustion.
Exhaustion, what's that?
If you provide a value that doesn't match any of the cases and you don't provide a default, a switch statement would just do nothing. It would fail silently.
Which is a hidden bug.
A hidden bug match, on the other hand, throws an unhandled matcher exception. It forces you to cover every single possibility. Again, it's about surfacing errors immediately rather than hiding them.
That seems to be a recurring theme here, forcing you to handle errors rather than letting things fail silently. Speaking of errors, let's talk about null. The source mentions null safety.
Null is often called the billion-dollar mistake in computer science. In old PHP, we used to see the error call to a member function on null all the time.
Oh, yeah. You'd try to get a user's address, but the user object was null for some reason, and the whole page would crash.
And your code would be filled with these ugly checks, like if set user address. Modern PHP gives us 2 amazing tools, the null coalescing operator and the null safe operator.
How do they work?
The null safe operator lets you chain calls like user.-getaddress.getCity.
Yeah.
And if any part of that chain is null, the whole thing just gracefully returns null instead of crashing.
That cleans up the code so much. No more of that deeply nested if statement nesting doll.
Exactly. And finally, for syntax, we have proper enums introduced in 8.1. We used to use class constants for things like status codes, const.status eval1, const.status published, east2, but they were just integers or strings.
So you could accidentally pass the number 5 into a function expecting a status and it wouldn't complain?
It would happily accept it. Enums give us proper type-safe categories. You can't accidentally pass a random integer where a status enum is expected anymore. The type system protects you.
So, okay, we've locked down the syntax. We have strict types, enums, mash expressions. We're basically writing bulletproof logic inside our files. But even the best code has to run some way.
Right. You can have the cleanest code in the world, but if you don't understand the execution model of the language, you're going to hit a wall.
And this is where PHP gets weird, because unlike almost every other modern web language, PHP has this shared nothing philosophy. How is that different from, say, Node.js or Java?
This is absolutely fundamental to understanding PHP. Think of a Node.js server, like a long-term hotel guest. They check in, they unpack their bags, they stay for weeks. If they make a mess in the room set, a global variable, or have a memory leak, it stays messy for the next person who uses that process.
Okay, that makes sense. And PHP.
PHP is the guy from the movie Memento.
No memory.
Zero. Every single web request is a brand new life. It boots up the entire application, it parses the script, it executes your code, and then, poof, it completely destroys itself. As the source says, everything dies.
Everything dies.
When a request finishes, the memory is freed, file handles are closed, database connections are terminated, and the slate is wiped completely clean.
That sounds incredibly wasteful, though. You're building the hotel room from scratch for every single guest who walks in the door.
It is wasteful in terms of CPU, which is why we have things like opcache to cheat a little, which we'll get to. But think about the stability it gives you. If your userland code has a memory leak.
It doesn't matter because the process dies 200 milliseconds later anyway.
Exactly. It makes PHP applications unbelievably resilient. You can write terrible leaky code, and the server will just shrug it off and reset for the next request. It also makes horizontal scaling trivial. You just add more servers. You don't have to worry about complex state management because there is no state.
But surely rebooting a whole framework like Laravel on every single request is expensive.
It is. That's the major con. Bootstrapping a heavy framework on every request takes a significant number of CPU cycles. And this is why opcache is not optional. It's absolutely vital for production.
Opcache, I've seen that in php.ini files. I usually just make sure it's on. What is it actually doing?
So PHP is a scripting language. By default, on every request, it has to read your human-readable PHP code from the disk, tokenize it, parse it, and compile it into opcodes, which are low-level machine instructions, every single time. That's a lot of redundant work.
And a lot of disk I/O.
A ton. Opcache intercepts that process. After the first time a file is compiled, Opcache stores the compiled bytecode in shared memory.
So for the next request, it just grabs the ready-to-go instructions from RAM.
Exactly. It skips the reading and compiling steps entirely. And the critical production setting, as the source points out, is opcache.validate timestamps.
0. What does that mean?
It tells PHP, never check the disk to see if the file has changed.
Wait, never. So if I deploy new code to the server, PHP won't see it.
Correct. Not until you explicitly clear the cache, usually by restarting the PHP FPM service. But the trade-off is massive performance because you eliminate all that disk I/O. It treats your PHP application almost like a pre-compiled binary that's just sitting in memory.
That makes a lot of sense for a production environment. The source also mentions JIT, or just-in-time compilation. There was a lot of hype about this in PHP 8.
Huge hype. The idea was that JIT would take the opcodes and compile them even further down to native machine code for even more speed.
Then did it work?
Yes, but the source provides a very important reality check. JIT is fantastic for CPU-intensive tasks, doing complex math, generating fractals, image processing. But standard web applications are I/O bound.
Meaning they spend most of their time waiting.
Exactly. They spend most of their time waiting for the database to return a result, or for an external API call to complete. Compiling the PHP code a few microseconds faster doesn't help you if you're waiting 100 milliseconds on a SQL query. So for most standard web apps, JIT offers negligible real-world gains.
Good to know. Don't obsess over JIT for a basic CR root app. Now, let's talk about object-oriented design rules. The source is very specific here, calling this one rule the single most important rule. Interfaces over implementation. Why is this so crucial?
It's all about decoupling your code. If your controller needs something to talk to the database, and you type hint that it needs a concrete MySQL database class, you are now permanently locked into MySQL.
You can't easily swap it for Postgres or something else later.
Right. But more importantly, you can't test it.
Why not?
Because when you run your unit tests, you don't want to actually connect to a real MySQL database. It's slow, and it requires a database to be running. You can't fake a MySQL database class easily.
So what's the alternative?
You type hint against a generic database interface. An interface is like a contract. It just says, whatever object you give me, it must have these methods: connect, query, disconnect.
So you're coding to a contract, not a specific tool.
Precisely. In production, you pass in the real MySQL database class, which implements that interface. But when you're running tests, you can pass in a fake in-memory mock database that also implements the interface. Your controller doesn't know or care about the difference. It just knows it can call the query method. It makes your code flexible and, most importantly, testable.
And this leads directly into dependency injection, or DI. Let's drill into this new keyword ban. It feels very restrictive. If I need a user object, why can't I just say user new user inside my method?
You can for simple data objects. A user object is probably fine, but you should never use new for services classes that do things.
Give me an example.
Imagine your registration controller needs to send an SMS when a user signs up. If you write TwilioCon, new Twilio client, right there in your controller method.
I'm locked into Twilio forever. If I want to switch to a different SMS provider, I have to go change the code in my controller.
Worse, much worse. Every time you run your automated test for that controller,
Oh, yeah.
you are literally sending a real SMS message.
Ouch. I'm paying for it.
And paying for it.
Okay.
By using dependency injection, you instead ask for a generic SEMIS interface in your controller's constructor. The framework service container then injects the real Twilio client in production, but you can configure it to inject a fake SEM sender during testing that just logs the message to a file. The controller code doesn't change, but its behavior does based on its environment. You are handing the class its tools rather than letting it build them itself.
That's a powerful concept. The source also warns about traits. I thought traits were a good thing, a way to get code reuse without inheritance.
They are, but they're also a trap. The source calls it the horizontal reuse trap.
Yeah.
The danger is using traits to create God objects.
Our God object.
Yeah, you just dump a bunch of unrelated utility functions into a trait and then use that trait everywhere. It hides the logic. It's very hard to see where a method is actually coming from, and it violates the single responsibility principle.
So how should we use them?
Use them for very specific orthogonal behavior that doesn't define what the class is, but what it can do. The source gives examples like HISUID or loggable. These are small, focused pieces of functionality. Don't use them to fake multiple inheritance for your core business logic.
Got it. Okay, let's shift gears to data handling and security. This is non-negotiable stuff. Let's start with the big one, SQL injection.
There is only one way to handle this in modern PHP: PDO and prepared statements. Never, ever, ever concatenate or interpolate strings into a SQL query.
I feel like we've been saying that for 20 years, but you still see it in the wild. People are still doing select from users where email,
They do. And to understand why prepared statements are the only safe way, you have to think like the database. Usually the database receives a full sentence of SQL. It parses that sentence to understand the command, and then it runs it.
An injection happens because I can sneak a command into the middle of that sentence inside my data.
Right, you can end the string and start a new command, like drop table users. But with prepared statements, you send the query template first. You say to the database, I am going to run this SQL query, select from users where email equals, here's the empty slot. The database compiles that structure, it locks it down, it knows what the command is.
So the plan is set in stone before the data arrives.
Exactly. Then, in a second step, you send the user's input. The database treats that input purely as data to be put into the slot. Even if I send the malicious string drop table users, the database just says, okay, he's searching for a user with the email address drop table users. It effectively neuters the input.
And for passwords, MD5 is dead, right? Please tell me MD5 is dead.
MD5 and SHA-1 are dangerously insecure. They are fast, which is bad for passwords, and they are susceptible to rainbow table attacks. The rule is simple. Don't DIY. Don't try to write your own hashing algorithm.
Use the built-in functions.
Yes, use the native password hash and password verify functions. They're designed by cryptographers to be secure.
And the cool thing about those functions is that they update themselves, right? The algorithm can change over time.
Yes, they are forward compatible. Currently, it defaults to bcrypt, which is a strong, slow hashing algorithm. If the industry standard changes in the future to Argon 2 or something else, the PHP core team can update the default, and your code doesn't necessarily need to change, just your PHP version. It future-proofs your password security.
What about web vulnerabilities like XSS, cross-site scripting?
This happens when you output user input directly onto a page. If I type a script tag into a comment field and you display it back to other users, my script runs in their browsers. The defense is context-aware escaping.
But the source suggests we shouldn't really be doing this manually with HTML special cars.
Right, because you'll forget. And the context matters. Escaping for HTML is different than escaping for a JavaScript variable. The best practice is to use a template engine like Twig, which comes with Symfony, or Blade, which comes with Laravel.
And they handle it automatically.
They auto-escape all variables by default. You have to explicitly tell them not to escape something if you want to output raw HTML. It flips the safety model from opt-in security to opt-out, which is much safer.
And CSRF, cross-site request forgery.
That's a tricky one. That's where a bad actor on another website tricks a logged-in user on your site into clicking a link that performs an action, like submitting a form to delete their account. Because the user is logged in, their browser sends a session cookie, and the server thinks the request is legitimate.
How do you stop that?
The defense is a hidden token. Every time you render a form, you generate a unique, random token and store it in the user session. When the form is submitted, the server checks that the submitted token matches the one in the session. If it's missing or doesn't match, the request is rejected. All major frameworks handle this for you.
Moving to data manipulation, specifically arrays. PHP loves arrays. They're like the Swiss Army knife of data structures.
PHP arrays are the workhorse. Under the hood, they are actually ordered hash maps, which makes them incredibly flexible. But the source argues we need to stop writing for each loops for simple operations.
Why? For each is so easy to read.
It is, but it can be verbose and error-prone for common tasks. The modern approach is to use functional programming primitives that are built into the language.
Like what?
Things like array map to transform every element in an array filter to remove elements that don't match a condition, and array brews to boil an array down to a single value. It's cleaner, less stateful, and often easier to read once you get used to the syntax.
And for massive data sets, the source mentions generators. This sounds like some kind of magic for memory management.
It basically is, and solves a very specific but very common problem. Say you need to process a CSV file that has 1 million rows. If you use a function like file or Faluge contents, PHP will try to load that entire million-row file into RAM.
And you'll immediately hit the memory limit exceeded fatal error.
Instantly. Your script will crash. A generator, on the other hand, allows you to iterate over the data one row at a time. It keeps only the single current row in memory.
How does it do that?
It uses the yield keyword instead of return. It basically says, here is one row of the CSV, go do what you need to do with it. When you're ready, I'll forget this one and get you the next one. It allows you to process gigabytes of data with just a few megabytes of RAM. It's incredibly powerful.
That is incredibly useful. Okay, let's step into the ring for the framework wars. The source identifies two main players in the modern PHP world, Laravel and Symfony.
And it makes a very important point first. Do not roll your own framework. It is a security risk, it is a maintenance nightmare, and it is a complete waste of time. Stand on the shoulders of giants.
So in the red corner, we have Laravel. What's its story?
Laravel is the get-it-done giant. Its philosophy is convention over configuration. It is optimized for developer happiness and speed of development.
It's known for being very elegant and easy to get started with.
Very. It uses some patterns that are sometimes controversial, like facades, which look like static calls but are actually resolved through the service container, and Eloquent, which is its active record ORM.
Active record means the model is the database row, right? The user object knows how to save itself.
Yes, you do username, new name, user save. The object is tightly coupled to the database persistence layer. This makes it incredibly fast for startups and rapid application development, or RAD. It feels almost like Apple products. It just works, but it hides a lot of magic from you.
And in the blue corner,
Symfony is the enterprise standard. It is much stricter and more verbose. Its philosophy is explicit configuration. Nothing happens by magic. Everything must be configured.
So it's more work up front.
A lot more work up front. It uses Doctrine as its default ORM, which is a data mapper.
How does data mapper differ from active record?
In a data mapper, the entity, the user object, is just a plain old PHP object, a POPO. It has no idea that a database even exists. It doesn't have a save method. You have a completely separate entity manager service that handles the persistence.
Yeah.
You have to explicitly say, entity manager persist.
User. That sounds more complicated. What's the benefit?
It requires more boilerplate, yes. But it is much better for very complex domain logic where your database schema doesn't perfectly match your object model. It gives you a clean separation of concerns. What's interesting is that Laravel itself is actually built on top of many of Symfony's components. They're not really enemies.
They're more like frenemies in the ecosystem. Now, regardless of the framework, we need to test our code. The source brings up the pyramid of testing.
Right. This is a model for how to balance your test suite. At the wide bottom of the pyramid, you have unit tests. These test a single class in complete isolation.
Very, very fast. Right?
Milliseconds. But they require mocking out all the dependencies. If your class talks to a database, you have to create a fake mock of that database connection.
And higher up the pyramid.
You have feature or integration tests. These test a slice of the application working together. For example, a user can register for an account. This test might actually hit a real but temporary database. They are slower, but they give you much more confidence that all the parts are working together correctly.
The source has a great rule here that I love. If you can't test it, you designed it wrong.
It's a harsh but essential truth. If your code is so tightly coupled that you can't write a simple unit test for it, it's a sign of bad design. Testability is a driver for good architecture.
There's one testing concept in the source here that I found absolutely fascinating. Mutation testing, and a tool called infection.
This is for the experts. This is how you find out if your tests are actually good. You might have 100% code coverage, which means your tests execute every line of your code.
But that doesn't mean they're actually asserting anything useful.
Exactly. Are they actually testing the logic? Or are they just running it? Mutation testing checks that for you.
How does it work? It sounds wild.
It creates mutants. It takes your production code and modifies it randomly. It'll change a plus sign to a sign. It'll change it for a cub. It'll delete a line of code. Then it runs your entire test suite against this broken, mutated code.
And you actually want the tests to fail.
Yes. If you change a plus to a minus and your tests still pass, it means your test wasn't actually checking the result of that calculation. The source calls this an escaped mutant. It's a brilliant way to test the quality of your tests. It's like sending a saboteur into your factory to see if your security systems actually notice.
That is a fantastic analogy. Okay, we are entering what the source calls the expert tier now. This is where we get into domain-driven design, or DDD. It starts with a discussion of anemic versus rich models.
Right. An anemic model is what you often see in simple applications. It's just a class that's a dumb bag of getters and setters. You can do user settage or user settage -10, and nothing stops you. All the business logic lives outside the object in service classes.
And a rich model.
A rich model moves the logic and the validation into the object itself. The settage method might throw an exception if you try to set an impossible age. The object is responsible for protecting its own integrity.
And this leads directly to the concept of value objects.
This is probably the highest ROI pattern you can learn in object-oriented design. It's the solution to a problem called primitive obsession.
Primitive obsession being the habit of using basic types like integers and strings for everything.
Exactly. Take money. The number 100 is just an integer. It has no context. It could be 100 cents, $100, or 100 yen. If you have a function that accidentally subtracts 50 yen from $100, the integer math works perfectly, but the result is complete nonsense.
So a value object wraps that primitive.
It wraps it with context and behavior. You create a money object. It contains both the amount and the currency. It is immutable, and it is self-validating. You can't have negative money if the object's constructor forbids it. The add method can check that you're not adding two different currencies. It makes your code safer and more expressive.
NDTOs, data transfer objects. Do we really need a whole separate class just to move data around? Why not just use an array?
Because arrays are unstructured and dangerous. When you receive an array, you have no guarantee about what keys it contains. You don't know if data email exists. You have to check is it constantly, and your IDE can't help you with autocomplete.
It's just a black box.
A total black box. A DPO is a simple typed object used to move data between layers of your application. It guarantees the structure of the data. Your IDE can autocomplete it, and static analysis tools like PHP stand can check it. It removes all the guesswork.
Let's talk database mastery. We mentioned version control for code with Git. The source says migrations are version control for your database schema.
That's exactly what they are. Each migration file is a timestamped set of instructions for how to alter the database schema. And the golden rule is, never change a migration once it has been deployed.
Why not? If I made a typo in a column name, why can't I just fix the file and redeploy?
Because that migration file has already run on the production database. The system tracks which migrations have run. If you just change the file, the system won't know it needs to run it again. Or worse, if you try to force it to rerun, it might crash or corrupt data.
So what's the solution?
You always move forward. You create a new migration file to fix the mistake in the old one. It's an immutable log of changes.
And you should always write the down method, right?
Absolutely. The up method applies the change, and the down method reverses it. You need an escape hatch. If a deployment fails, you need to be able to instantly and reliably roll back the database schema to the previous state.
The source also mentions the N+1 problem. This seems to be the classic performance killer in almost any ORM.
It is the single most common reason for slow loading pages. It happens when you load a list of items, and then inside a loop, you load a related item for each one.
For example, fetching 50 blog posts and then looping through them to fetch the author for each post.
Exactly. You end up running one query to get the 50 posts, and then n, in this case, 50 additional queries to get the authors. You've run 51 database queries for one page load.
And the database latency just kills your performance.
It absolutely destroys it. The fix is called eager loading. Most ORMs provide a way to do this. In Laravel, it would be something like post.withAuthor-get.
And that tells the ORM to be smart about it.
It tells the ORM your plan. It then runs exactly 2 queries. One to get all 50 posts, and a second query like select from authors where it in to get all 50 authors at once. Then it stitches the data together in memory. It scales perfectly. It's a one-line change that can make a page 100 times faster.
Now let's get to the really futuristic stuff, advanced systems and asynchronous PHP. We established earlier that PHP is shared nothing and that everything dies, but sometimes we need to break that rule.
We do. The first and most common way is with queues. PHP's request-response cycle is single-threaded. If a user registers, you don't want to make them sit there staring at a loading spinner for 5 seconds while your server talks to an SMTP server to send a welcome email.
That's terrible user experience.
It's awful. So you offload that slow work, you push a send welcome email job onto a queue, which is usually backed by a fast in-memory store like Redis. Then a separate long-running background worker process picks up that job and handles it. The user gets an instant success response.
And you use a tool like Supervisor to keep those worker processes running.
Yes, because remember, PHP scripts want to die after they're done. Supervisor is a process manager that forces the worker script to stay alive, or restarts it immediately if it crashes.
But then there are tools like Swool and FrankenPHP. These sound like they fundamentally change how PHP works.
They do. They are application servers that run PHP in a persistent, event-driven loop, much like Node.js.
Okay, let's talk about FrankenPHP. This sounds like we're resurrecting a monster.
In a way, we are. We are breaking the one sacred rule we discussed earlier. Everything dies. With FrankenPHP, your application boots once, and it stays in memory between requests.
So my variables, they don't get reset. The memory isn't wiped.
They do not. And that is both powerful and terrifying. If you accidentally append a user's ID to a static array on every request,
An array just grows forever.
it grows and grows until your server crashes with an out-of-memory error.
Yeah.
You have to unlearn a decade of PHP habits. You have to be meticulous about cleaning up after yourself. But the payoff. We are seeing benchmarks where these tools allow PHP to outperform Go and Node.js. We're talking tens of thousands of requests per second from a single machine.
And fibers, that sounds like dietary advice.
It does. PHP 8.1 introduced fibers. They're essentially green threads or lightweight coroutines. They allow for cooperative multitasking within a single thread.
In simple terms.
It allows you to write asynchronous code that looks synchronous. It lets you pause and resume a function's execution without the callback hell that you often see in old JavaScript code. It's the low-level building block for the next generation of high-performance async PHP frameworks.
The source is a really cool example for streams that I wanted to touch on, the Zero Disk I/O zip download.
This is a hidden gem in PHP that most people don't know about. Imagine a user wants to download a zip file containing 500 generated PDFs. The naive way to do this is to generate all 500 PDFs, save them to the server's disk, zip them up into a single file, send that file to the user, and then remember to delete all the temporary files.
Which is incredibly slow and fills up your hard drive.
It's a disaster.
Right.
With PHP streams, specifically the php.output stream, you can generate the zip file and stream it directly to the browser's response. Think of it like a bucket brigade. You generate one chunk of the zip file in memory, you hand it directly to the browser, and then you forget about it. You never write a single byte to your server's disk. It looks like magic to the user.
That is absolutely brilliant. Let's touch on caching architecture. The source warns about the cache stampede.
This is also known as the thundering herd problem. Imagine you have a very expensive database query that you cache for 60 seconds. At exactly 12.000000001, 1,000 user requests hit your server at the same time.
They all see the cache is empty.
And they all try to run that expensive query at the exact same time to regenerate the cache.
And the database just melts.
Instant death. The solution is to use atomic locks. Only one process is allowed to acquire a lock to regenerate the cache. The other 999 processes either wait for the lock to be released or are served slightly stale data. Another solution is probabilistic early expiration, where you randomly expire the cache a bit early for some users to trigger a background refresh before the herd arrives.
And cache tags, what problem do they solve?
They solve the problem of cache invalidation. If you cache a user's profile data, their order history, and their account stats under 3 different cache keys, how do you clear all of them when the user updates their profile? With tags, you can tag all 3 of those cache keys with user.1. Then, you could just flush the user.1 tag, and all associated cache items are invalidated at once.
We're in the home stretch now. Section 8, maintenance, security hardening, and the future. Security hardening goes beyond just SQL injection. Let's talk about sodium.
The old standard for encryption in PHP was the open sling crypt function, but it's very easy to use incorrectly. You have to manually manage initialization vectors, padding, and authentication tags. libsodium is the modern standard. It's bundled with PHP now, and it is designed to be foolproof. It's very hard to mess it up.
And timing attacks. This sounds like something out of a spy movie.
It's a very real and subtle vulnerability. When you compare 2 strings in most languages, like checking a password hash or an API token, the standard comparison returns false as soon as it finds the first mismatch.
So if the very first letter is wrong, it returns false almost instantly. But if the first 10 letters are right, it takes a few nanoseconds longer.
Exactly. An attacker can precisely measure that time difference to guess the string 1 character at a time. It's a side channel attack. The fix is to use the hash equals function, which performs the comparison in constant time, meaning it takes the same amount of time regardless of where the mismatch occurs.
That is incredibly subtle, but so important. What about CSP?
Content security policy. It's an HTTP header you send to the browser. It's a whitelist. It tells the browser you are only allowed to load scripts from these trusted domains. Even if an attacker manages to find an XSS vulnerability and inject the script tag, the browser will refuse to run it because the source of the script violates the policy. It's a powerful second line of defense.
Now, for all the developers fighting legacy code out there, the source mentions a tool called Rector.
Rector is a game changer. It is a command line tool that upgrades your code automatically. It doesn't just use regular expressions. It parses your code into an abstract syntax tree, or AST, understands it, and then programmatically rewrites it.
So if I have a massive project on PHP 7.4 and I want to upgrade it to 8.2, Rector can just do it.
It can automate 95% of the grunt work. It will add strict type declarations. It will change your old switch statements to match expressions. It will apply constructor property promotion. The professional workflow the source recommends is run Rector to upgrade, run a code style fixer like CSFixer to format, run PHP stand to check for type errors, and finally run your test to verify the logic is still correct. It's like having a robot janitor that refactors your entire codebase.
And if the legacy app is just too big and scary to rewrite all at once, the source suggests the strangler fig pattern.
Yes, named after the fig tree that grows around another tree and eventually strangles it. You don't do a full rewrite from scratch. That's called the second system effect, and it almost always fails. Instead, you put a new, modern framework next to the old one. You put a reverse proxy in front and route traffic to a new front controller.
And you just migrate one single route at a time.
Exactly. This week, you rewrite the login page in the new system. You configure the proxy to route login traffic to your new app. Everything else still goes to the legacy system. You slowly and safely strangle the old system piece by piece until nothing is left. It's a low-risk, incremental approach to modernization.
Finally, file systems. The source mentions a library called FlySystem.
The rule here is never to hard-code file system paths like var whooploads in your code. FlySystem is an abstraction layer. It gives you a generic disk that you can write to. In your configuration, that disk can be a local folder on your laptop for development, but in production, you just swap the driver to Amazon S3 or Google Cloud Storage.
And the application code doesn't change at all.
Not a single line of code changes. It completely decouples your application from the underlying storage, preventing vendor lock-in and making your environments flexible.
Amazing. We have covered a massive amount of ground, from the blue-collar reality of PHP's dominance to the expert-tier architectural patterns. The source wraps up with a senior developer checklist. What's on that list for today's PHP developer?
To call yourself a senior PHP developer today, the checklist is crystal clear. 1. Type everything. No more loosey-goosey typing. 2. Master Composer and understand the critical importance of a lock file. 3. Use dependency injection religiously. Stop using new for services. 4. Write tests. If you can't test it, you designed it wrong. 5. Understand performance opcat is mandatory, and you must know how to spot and fix an N+1 problem. And finally, you must use the tools of the trade. Docker for local development, CI/CD pipelines for deployment, and static analysis in your workflow.
It's not just about getting it to work anymore, is it? It's about craftsmanship.
Not at all. The source puts it perfectly. Juniors copy-paste the happy path solution from a tutorial. Seniors consider the failure states. They asked, what if the database is down? What if the user input is malicious? What if this file is huge? How will the next developer maintain this code in 2 years?
The source ends with a final, provocative thought that I think is the perfect place to leave our listeners.
It's a great one. PHP is a sharp knife. You can carve a masterpiece or cut your fingers off.
And the tools we've discussed today, all the strict typing, static analysis, and design patterns.
They are your safety gloves.
So to all the developers out there, whether you're maintaining a massive legacy monolith or spinning up a new Franken PHP microservice, put on those gloves. Go build something solid. Thanks for diving in with us.
Until next time.